Hello everyone, let's solve another problem. The function s of n is defined for positive integers n by s of n is equal to the sum of the digits of n. For example, s of 723 is equal to 7 plus 2 plus 3, which is equal to 12. The sum s1 plus s2 plus s3 up to s99 equals 746, 862, 900, or 924. Okay, this seems like a pretty cool problem. It looks like the first thing we should do is, write integers in terms of their base 10 expansion. And then maybe what we can do is in the large sum, S1 up to S99, we might be able to rearrange all the terms, like all these individual terms. S of 19, for example, can be split into two numbers, a 1 and a 9, the tens digit and the 1 digit. And maybe if we just rearrange all these things and count up how many, add up all the tens digits separately and all the ones digits separately, that might give us the answer. What is a good way to arrange this all? So I'm going to break this up into like fairly detailed breakdown. If I were doing this, directly, just simply for my own purposes, without trying to illustrate what's happening, I might do this. I might do a lot of this organization in my head, but so that you can see what I'm thinking, I'm going to try and write things down in a more expanded way. Okay, so what I've listed here are all the digits, and I'm only thinking about their occurrence in the ones spot, so in the 10 to the power of 0 spot of the decimal expansion. And I want to count now how many times these digits appear in the list of numbers from 1 to 99. So the digit 1 will appear here. It'll appear in 11, 21, 31, and so on. So it appears 10 times. The number 2 also appears 10 times. In fact, all of these will appear 10 times except for 0. Well, 0 won't matter, right? Because we're adding, 0, does it come in 9 times or does it come in 10 times? Yeah, 9 times because we're missing s of 0. But it's not going to affect the total sum. Okay? Now we'll do the same thing with the tens digits. So the number 1 appears 10 times from 10, 11, 12 up to 19. 20, the number 2 appears 10 times in the tens digit for all the 20s. And this holds all the way up, including 9, right, from 90 up to 99. The 0, I guess you could say it appears 9 times in this list, but it's not really going to matter because the 0 is not going to contribute anything to the sum. So we're really just writing out all the numbers from 1 to 99, writing out all the numbers, but then adding up only the digits in those numbers. So the way I'm going to do this, these columns here won't matter, those final columns. So what I'll do to sort of quickly get this total sum, I'll add up all these numbers. That'll give me something. I'll multiply that total by 10 because each of these appears 10 times. And then I'll multiply that total by 2 to account for the fact that I basically have to do this twice. So I happen to know that 1 plus 2 up to 9, this is equal to 45. And then I have 45 times 10 is 450. And then 450 times 2 is equal to 900. Oh. And I hope that is one of the options given in the multiple choice for this question. It is. So option C is 900. Yeah, fairly confident in this answer. I thought this question was going to be a little bit more complicated when I first glanced at it. Anytime you're doing something that has to do with breaking up a number into digits can be a little bit fussy or finicky, but once you realize exactly what's going on with the larger sum here, that you're just, maybe counting the number of occurrences of these digits is not the most elegant way to do it, but it kind of condensed the total sum that I had to do into something pretty quick. So 900 is my answer, but if I find a mistake or if I have any more comments, I'll put them down in the description. Thanks for watching.